What if we left today? What if we said goodbye to safe and sound?
Okay, welcome back. So I'd like to welcome Jonas. Jonas Ohlsson from State. He spoke here about 9-10 months ago about isomorphic rendering, which is a really good talk. Today he's going to talk about using Redux. Jonas, thank you.
Yeah, all right. Can everyone hear me? Yeah? Okay, let's start. Thanks everyone for coming. I hope you're excited to be here, as I am. Like I said last time when I spoke here about 9 months ago, I love this community. I love this meetup. I think it's so awesome that we're teaching each other, showing each other what we're doing, and pushing everything forward to do our things better and better and get better and better tech. So today I'm going to speak about how to use Redux to maximize development efficiency. And before I start, I want to quickly go over why I think Redux is natural, because I know that, as always on the web, there's this big discussion about we have more and more tools, more and more complicated tech stacks, and people get confused. Do we really need one more thing if it isn't something we weren't using already? So just quickly, I think we can all agree, right, that if you look historically on the products we build on the web, they have increased in complexity over the years. Like a few years ago, or maybe say 5-10 years ago, everyone was pretty much writing static websites. And at least in the terms of what we as web developers were iterating on in terms of, say, state in the client in, say, JavaScript, there wasn't much there. Right? We didn't have complicated flows, user flows in our applications. But as we've moved more and more towards single-page applications and more complicated single-page applications, there's more and more of a need to have good tools to enable us to debug and iterate on these kind of applications. So with static websites, it was kind of fine to refresh a page every time you made a change because the change was most likely in server code, and you didn't have, say, complicated wizards or multi-view modals and things like that you needed to click through multiple steps just to get back to where you were every time you made a change in your code. So it was fine to refresh the page. But after a while, we introduced tools like live reload for our styles because we realized when we were tweaking like pixel values up and down to get everything to just the perfect state, it was really annoying to refresh the page every time. And around when these tools existed back then, we didn't have such good dev tools in the browsers as we do now. So we needed browser plugins or whatever to get live reloading in CSS. And eventually, about a year or so ago, Dan Abramov introduced hot module reloading to get similar functionality for our JavaScript, because now we're often tweaking in JavaScript instead, and it's really frustrating to refresh the page every time you make a change. But as Dan said, when he introduced hot module reloading with a normal, say, React application only takes us so far, because you can only hot module reload stateful functions. You can't hot reload something that needs to keep persistent state, like a store. If you hot module reload it, it will lose its state and go back to the beginning, the initial state. So that's why we need something like Redux to manage the complexity and manage our states and keep our state while we develop the more complex applications that we have today. All right, let's just show a quick demo on what I mean with all of this. What a demo of using Redux in an application today looks like practically. OK, as long as I can get out to my thing, yeah? Then I need to look over there. OK, so quick demo. So with hot module reloading, I hope this is big enough, yes. If you've seen it already, this is a no-brainer for you. First of all, this is the site I'm going to show in this talk as an example. It's just a simple site I've built for generating critical CSS for your site. So it's very simple. You just write a URL over there, hit enter, it hits the server, and eventually it gives you critical CSS, which you can use to improve the performance of your website. But with hot module reloading, we can do things like changing our application live, save, and get the change injected into our browser without refreshing the page and without losing the state, so the modal keeps open. And this is awesome. This really improves our efficiency. But using a normal Flux flow, there's only so far we can push this. If we write our components and everything functional, we can hot module reload all of that, but we can never hot module reload something like the logic in our stores. But that's where Redux comes in and actually enables us to do exactly that as well. So with this logic here, for example, if I hit to regenerate the styles for that particular URL, it doesn't look like it inserts an extra row in the table. It just replaces it. But actually, what the code does is it filters the table by URL. So that's why it didn't show up twice. But I can live update this and immediately get all my duplicates showing in my code, in my browser, even though this code previously, historically in React, would have been stateful. And then that wouldn't have worked. So now let's go back into Keynote. All right, so that's my React demo, and I need to play this again. Now, before we go into the theory and more about what Redux actually is and how it works, quickly, so my name is Jonas Ohlsson. I'm a front-end developer. I work at State. I'm really passionate about performance, about tooling, and React, and all the tools we have. And I wrote Penthouse a while ago, which is a critical CSS generator. And in this talk, I'm going to talk about what Redux is, and overview, and why you should use it very quickly. And then I will just go through a simple data flow through the application that I just showed you, the critical CSS application, and show what it looks like in practice. So first of all, what is Redux? So Redux is a predictable state container. So it keeps all of your state, and it is predictable. And you can think of it as the evolution of Flux, even though I know when it was introduced, that had no intention of writing a Flux framework. But effectively, if you use Redux, you will use it in place of what you are using currently for your Flux. It replaces any other Flux pattern. And one really crucial concept in Redux is that you have one state object in one place in all of your application. So I think of it as, if you have a traditional React application, you might have some local state in a component that has a form. You might have state for data that you have fetched, and you have state listed all over your application. I think of like taking a hover or something like that, and you're just going through all of your application, you're just sucking up all the state and putting it somewhere else, putting it into Redux instead. But that state needs to be immutable, otherwise hot module reloading and all these things don't work. One more really crucial concept of Redux is that we will no longer write stores, because stores are the stateful part of Flux applications, and that is what we need to get rid of. So we will write reducers instead. And I will explain what reducers are soon. And like I showed in the demo, Redux enabled us to hot module reload all of our code, and it also enabled us to do some time traveling, which I forgot to demo, but basically we can go back and forth in time. We can undo actions that have happened and enable them again. And there are other great demos of using Redux and hot module reloading that I will link to later in the presentation. But other benefits of using Redux, reasons why it's really awesome is, so Redux is not this big, massive thing that will weigh down your production code. Redux is really small, first of all. It's really few lines of code. But it uses really powerful concepts. But it's only about 2 kilobytes. And another important thing is that Redux on its own is not coupled to React. It's completely standalone. So everything you write in Redux, you can theoretically, you can keep if you would want to replace React with something else down the line. And that's always a good feature. And the final thing on my very long slide of things I think is awesome with Redux is that Redux and the documentation on Redux and all the kind of ecosystem of tools related to Redux, they all recommend and document best practice, so that if you look at all the awesome, it's really well documented in general, if you look at them, how they suggest for you to use Redux, you will not only get the benefits of Redux itself, you will get all the benefits of having a really solid architecture in your application that will enable it to scale in a much nicer way and make it easier to test and reason about. So, okay, just to anchor us quickly, like I said, Redux was kind of like a Flux framework. How does it compare to other Flux frameworks? So this is the data flow that I've drawn for Redux. And hopefully, it looks familiar. It looks like something you've seen before. So in Redux, our data flows through actions into reducers, which is this new concept that I will talk about next, into a store, but that's no longer a store that we write and manage. It's a Redux store that Redux handles for us. And finally into the view. And compared to the traditional Flux, it's pretty much the same, just that we've introduced reducers and we no longer have a single dispatcher. But it's essentially the same. So next I will talk about, I'll just show in practice what actual Redux code looks like in an application, in the application I just showed you. So I will just talk through the data flow of entering a URL into this kind of form, into this field, clicking generate, and having that data flow through the application into the table of results that sits below that. So we will look at dispatching an action, updating the state via our reducer, and receiving the state finally in the component, in the table at the bottom. So let's start. So we start with an action creator. So action creators in Redux are exactly the same as action creators in other Flux frameworks. Actions in Flux are pure JavaScript objects, most typically, and we pass along the information that we need for this action. So in this case, when we generate a new critical CSS, we always need a type. In this case, we need a URL, and because URL is not unique, we also need an ID. The only thing to notice with action creators in Redux is that compared to other Flux frameworks, action creators here do not dispatch actions. They only return them. So we will ourselves later have to dispatch these actions. And this is something that can trip you up if you come from something else. If you expect calling this function, calling this action creator to have the action dispatched for yourself, you need to dispatch it yourself later. But then we go into reducers, which is the new concept in Redux. And essentially, if you use to a different Flux framework, you will write reducers instead of stores. Where you previously had stores, you will now write reducers. And they're basically stores without all the crufts, without the state and all other things that stores traditionally have. Instead, reducers are just pure functions. So they're pure, meaning that they don't keep any state, they don't hold on to anything. And you call them, the signature of a reducer is that it accepts the current state and the action that was called, and from that, it generates the next state without having any side effects. And the name, by the way, of the reducer comes from, the name comes from the reduce function on arrays, because the signature is the same. But let's look at the reducer in our example, the reducer for results, for handling this action of generating new CSS, critical CSS, which will eventually go into this display in this results table. So the critical thing, now if you look at the signature first, it is just what I said. So a reducer receives the current state and the action. So there are two things to note here with the state that it receives. So I said that just like we have multiple stores in a Flux framework, we now have multiple reducers. So when I say that the reducer receives the state, it doesn't receive the whole state of your application. It receives the part of the state that that reducer is responsible for. So a results reducer would only receive the results part of the global state and not the whole state. And the other thing is that I'm using ES6 syntax here for assigning a default value to the state that the function receives. And that's because you have to handle the case where there is no current state yet. The very, very first time this reducer is called, the state will be undefined, and you need to handle that as well so that you return something that's consistent. So this is a results reducer. It will handle an array of results, so the initial state will be an empty array. Then let's just look at the reducer itself. It's pretty simple. So we look at the type of the action that we received, just as you do in any Flux framework. And then for this case where we have an array, we insert a new item. In this case, we're just interested in an ID in the URL and a status that tells the table to render a spinner. And then we want to combine this new item with the existing state, with the existing array. And the important thing to notice here is just that we use something like concat and not push on the array, because the state is immutable. We cannot modify it. And push mutates the array and concat instead creates a new one. So that's why we use concat. Or you can use the spread operator if you use ES6 to do it in a more terse way. But it's really important that you don't mutate the store here. And the only final thing to notice that's really important in a reducer is that every reducer gets called every time you have a new action is dispatched. But most of the time, for most actions, most reducers don't care about. So you need to return some kind of default state in those cases. Because remember, the state only flows through these reducers. It's never kept here. So if you didn't return anything, if you didn't return the current state when you don't handle the action, then it would just break and your current state would become undefined. You need to pass it through so the state continues to work in these cases. Finally, after our reducers, we go into the store, which now is a Redux store that looks like this. It's quite simple for you to use. So first, before we can call the store, we need to combine all our reducers into one single reducer. Because as I said, as you previously would have had multiple stores, you will now have multiple reducers. And the Redux store accepts a single reducer to create its store from. So you use combine reducer from the Redux API to create one single root reducer that holds one single state that is a combination of all the individual small state objects that your individual reducers return. Then you create a Redux store with a equally simple create store API call from Redux. And it just accepts the root reducer that you just created, as well as an initial state. And you don't have to pass any initial state. It's optional. If you're only doing client-side rendering, your initial state might be, you might not have any initial state, and it's fine to just omit that parameter if so. But if you did, for example, server-side rendering, this is where you would plug in an initial state that you got from your server. And also, if you do things like what Olli was saying in the previous talk, if you save away the state of your application, for example, when you hit errors, you could plug it in. You could plug in that very state here and start your application from that particular point. But then, thirdly, this store has everything that we would expect from a store in a Flux framework. It has a get state and subscribe methods, which you can use to hook up your views so that they get data from the store. And the very final method that we need to know about is that the store has the dispatch call. Because remember what I said before, the action creators in Redux are just functions. They just return the actions, but we need to dispatch them ourselves. And we do that by calling dispatch via the Redux store. And you could think that we would be done here, but actually I'm going to modify the flow I showed you before. And I'm going to say that we can do slightly better. So everything I showed you so far has been Redux on its own and completely separated from React. And completely library or framework agnostic, so you can use it with any framework. But if we know that we're going to use Redux, we can use a helper library called react-redux to make it a little bit nicer for us in our React applications. So we use components called provider and connect from this library. And provider is super simple. You just wrap your whole application in the provider component, pass it the Redux store that we just created, and it will just be, the provider is just responsible for making your Redux store available to all your components so that you don't yourself have to pass it through as props throughout your whole application or import it everywhere. It takes care of that for you. And connect is the more interesting bit. So one of the benefits of using Redux, and especially using a library like Connect, is that it allows us to more easily keep our components super dumb and simple, which makes them really easy to reason about and to test. So this is a really simplified and dumb version of the results table that I had shown you previously, where this data that we're going through, passing through in the flow, is going to end up. And ideally, we want our components to be stateless, and we want them to be pure and completely only depend on the props that they receive. But these results here that I'm using in the props, they are the results that the results reducer produced that we put in the Redux Store, but how do we get them from the Redux Store into the actual component? So this is where connect comes in. And what the connect library, the connect call from the react-redux library does is that it wraps the component, the actual results table component that I created at the top, into a higher order component, which you can inject, for example, props from the state into. But then the important thing is that it's the higher order, the connected higher order component is the one that your application actually ends up using, not the results table components here. But you only need to kind of manage your results table, the simple DOM component yourself. And when you test things, for example, you can also test the results table components itself. You can keep everything much simpler. And so how to get the props from the state via connect? The first parameter to the connect library is a map state to props component, which receives the state as the first argument, from which I'm using ES6 destructuring, and I'm grabbing the results part of the global state. And then I'm returning an object, again with ES6, where I'm returning an object with the key value both being results. And this object with the results then gets injected into the props that the results table receives. So if it had other props as well that it received from its parent, it would receive both results and any other props that it had already. So this is really nice in that we can structure our code like this and basically get all the benefits of keeping our components dumb and simple. And there are a few more things to mention. Whenever you use connect and the map states to props function to grab some props from the global state, react-redux takes care of subscribing you to the store, basically, setting up calling the subscribe event on the Redux store, and also unsubscribing if the component gets unmounted, which means that as soon as the state changes with the results, that will get flown down into your application. But it's boilerplate that you don't need to write yourself. And yeah, like I said, it's a huge win that you can so easily keep your component dumb. Then the final step in the data flow that I'm showing is what I didn't talk about yet, how we started off, how we dispatched the action from the component. So in this case, it was this component that you type a URL into and click generate. How do we dispatch the action to start it off? So if the component looks like this with a simple URL label and an input, and then we have a button where we want to call the request generate action creator, this is where we might get tripped up and think that calling that function on its own is enough. But like I said in the beginning, the action creator only returns an action object, but we need to dispatch that action in order for it to flow through our application. So this won't work. What we need to do is use connect again. This is the easiest way. So anytime you call connect on a component, it automatically injects the dispatch that we had on the Redux store into the component props. So when we call this.props.dispatch, it's equal to calling Redux store.dispatch. And then we can dispatch the action as we should, and this will work. But react-redux also provides a little bit of a nicer, I think personally, API if you want to use multiple action creators in the same component. The second argument that the connect call takes is can accept an object where it expects all the values to be action creators with the same name as what the key is. And it will inject all these action creators as props onto the props into the component, but they will now be auto-bound to dispatch themselves, so that this time when we call the request generate inside a component, now on the props, it will dispatch the action, and it will work. And that's basically what it looks like to use Redux in a simple application flow. So the high level of using Redux in your application is you will write reducers instead of stores. And using Connect, you can take advantage of Connect to keep your components dumb, which has massive benefits in terms of making it easy to reason about and making it easy to test. And yeah, doing all of this, we benefit from being able to use hot module reloading throughout all of our application. We get to use powerful dev tools that I didn't really show today, but they're well documented in places around the internet. And we get components, like I said, that are easy to understand and test. And that's all. I have lots of resources on these slides that I will tweet on my Twitter. My Twitter handle is PocketJoe. So if you're interested in diving into Redux after this, I recommend you to look into, for example, Dan Abramov's. He did an excellent video series on breaks down all the low level, exactly how Redux works. And the docs are really great. And yeah, there are lots of other good resources out there. So go check it out. But yeah, if you're not using Redux, go and use it. Redux is awesome. Thank you.
Thank you, Jonas. Really good. Any questions? Any questions for Jonas?
Thanks for the great talk. I've also enjoyed using Redux a lot. It's definitely an improvement over standard Flux patterns. One frustration I have, though, I was hoping for guidance, is that when I use combined reducers, I'm basically namespacing different parts of my state to kind of cause separation, which is a good thing. But sometimes you do want to actually, in your reducers, to reach into other namespaces within your state. How do you get around that?
You want to use part of the state from other reducers inside your reducer?
Well, no, not other reducers, the other parts of the state. So when you use combined reducers, the part of the state, let's say your reducer is called logged in user, then the part of the state passed into your reducer is the logged in state subtree of your entire state, not the entire state. But what if I want to reach into another part of the state inside my reducer method? That I keep coming up with that with a lot, and I'm wondering if I'm doing something wrong.
To be honest, I haven't had that happen to myself yet, and I don't know if I have the right answer. Well, what I would believe is that you should be able to structure your application state in a way that wouldn't be necessary. That's what I would think would be the right answer. And there are something I didn't mention so much in this talk, but there are some great articles available. One of which I'm listing in these resources, on how to design your application state when using Redux. Because you're passing around, you have this one big blob that you're passing around and that everything uses. It's quite important to get that right, and it really helps you lay out your application. And I think that's the way to get around it, to think about how your state should be structured so that that's not necessary. You shouldn't have to. I don't think you should have to reach into.
Okay, thank you. Just because there was implication that I hadn't thought about it, I must say. So a logged in user, very specific case, you have some sub part of your state that you store some completely unrelated information in. Sometimes you want to do different things to it based on whether it's the current logged in user's information or somebody else's information, if you have a multi-user system. How do you actually keep that dry? Do you pass it in every single action you pass that bit, or?
Like I said, I don't have direct experience with that, but yes, I would probably pass a different action depending on whether you had a logged in user or not, or pass that information along in the payload of the action. Dan, do you want to say something about that?
Just feel free to go back to it later.
All right. Dan is.
Somebody has questions about Redux. A nice thing to do. Yeah, sorry. Hi. So my name is Dan. I actually wrote this library.
I just want to say that if you have questions about Redux, if something is not clear, if you have like some scenario that doesn't quite work out, you're not sure what to do, what you can do is create a Stack Overflow question and DM me on Twitter. My nickname on Twitter is Dan Abramov with an underscore in between. Just write me a direct message. My direct messages are open, and I'll try my best to answer all questions on Stack Overflow. Thank you.
Awesome. It's awesome, Dan.
Sorry.
All right.
So with Connect, how do you balance between connecting every single component, let's say, or just one top-level component and passing props all the way down?
So I think there are different ways of doing it. There are pros and cons of doing it either way. You can. I mean, you don't have to use Connect at all, right? You could receive the full state. You could hook up your top app component, even using manually the Redux Store's subscribe and get state APIs, and then pass everything down. But I think it just locks you into the current problem. You know, it makes it much harder to change the way your state is structured or the name of things. And the way I've personally done it is to, nowadays, I only use props for not things that, props that I pass between components, I only use for things that don't come from the application state, basically. So to say that over here I want a red button, and here I want a blue button, and that I can use props for, but I wouldn't use props anymore for things that I can get from the application state, because I use Connect instead, and because it has lots of benefits. But obviously, when you do use Connect everywhere, it means you're creating extra divs and extra components. But actually, there was one more thing I forgot to say about Connect. Connect is awesome. I would say like use Connect. So Connect also assumes that your component, the one you're connecting, is pure, and it will also implement equivalent to should component update function on it. So you also get out of the box like performance benefits compared to if you weren't doing that on your own. So I would favor going with Connect, but yeah, depends on what you want to do.
Use stateless function components.
Should I say something about stateless function components? So stateless function components, if you know about this in React, components that no longer need to be components, components that can now be, since React 14 can be used functions instead. Without any render method, they assume that what you return in the function is JSX. I don't use those yet with Redux and hot module reloading, because unfortunately it still isn't supported with hot module reloading. But it's going to be supported soon. Soonish. But I mean, if you want to use stateless functional components in React and you want to use Redux and hot module reloading, just use the component class still, but write them in the exact same way without using any lifecycle methods or any state, and then you can easily convert them once it's ready. There are also other methods, hacks around enabling using stateless function components with hot module reloading. Yeah, Dan? Maybe.
Yeah, I just want to say that I thought a bit about the question that was before, and since everybody's probably interested in the question. So the question was, what do you do when one reducer cares about the state of some other reducer and wants to kind of do different things depending on that state? So yeah, one of the ways to do that would be to dispatch different information in the action depending on the current state. But it's a bit less predictable and kind of not very nice. So the way I usually approach these kind of things is that instead of using combined reducers, which is like default way of combining several reducers, I just write this function by hand because compile reducers just generates a reducer calling other reducers, but it's just a function, so you can write it by hand. And when you write it by hand, you can actually break the conventions and you can pass any kind of arbitrary information that you want to pass. So for example, you can call one reducer first, get its value, like gets its new state, and then pass this kind of state that everybody is interested in as the third argument to other reducers if you want them to kind of have access to the state. So you're just making the data dependencies explicit this way. And another case where people want kind of reducers to know about each other's state is when you have some kind of computed data. Like in Flux, you usually have a store that listens to a couple of other stores and works on the data from them. But in Redux, when possible, you should keep the minimal possible state in the store, and then you should calculate the derived state inside. We call them selectors. So you might want to look up a library called reselect, which is a performant way of doing selectors. But basically, selectors are just functions that take the state and return something, and you can compose them. And the idea is that you should, if you have something that depends on several parts of the state, you can just write a selector that uses both of these parts of the state and calculate something else. And you can use reselect to make that selector performant to minimize the last calculated values so it doesn't perform unnecessary recalculations all the time. So yeah, hope that answers the question.
Just to point that out, I didn't point it out during the presentation. What we call selectors are the function named map state to props here. That's what Dan is talking about. That is the selector function that selects what out of the global state we want to use in this component. All right.
Hello. I was wondering, maybe I just didn't get it from the presentation. What was the main reason that you separated the dispatch function and a generate a request function? What was the main benefit? Because from the demo which I seen, basically you wrap it. So what is the benefit or upside of it?
Are you asking why action creators do not dispatch?
Function and generate request. Why is it separated? Because you wrap it together. So what is the benefit? Maybe I just didn't get it from the presentation.
Yeah, so I believe your question is why action creators do not dispatch actions themselves.
Yeah, exactly.
So I believe the reason that's done that way in Redux is because it makes it easier to test your action creators, and it just separates. Huh? And server rendering. Yeah, let's see what Dan has to say.
Yeah, so
Lifesaver.
I'm sorry for hijacking this presentation. Yeah, so the reason we did that is because with server rendering, you don't really have a single tone thing you can dispatch on. You don't have a single dispatcher or the store that is a singleton. In server rendering, you want to have a different store instance per request, because different users have different data, and it's pretty complicated to try to emulate that with vanilla Flux store that is just a singleton. So if you want the action creators to actually call dispatch, you need to somehow have access to this dispatch at the time of defining action creator, which leads you to a singleton, and singletons are problematic, so we don't do that. Thank you.
Yeah. Oh, that's right.
Thanks.
Any other questions? Great. Okay. Thank you, Jonas. That's brilliant. Thank you very much.
Thank you.